Node Wizard and Node Client. Developed by the Cluster Wizard project team. Node Wizard and Node Client. Let's start by giving a quick introduction to Node Wizard and Node Client. Node Wizard is an agent for VM lifecycle management. This tool allows us to create, start, shut down, destroy, and delete VMs. Along with this, Node Wizard can attach bridges and host devices to a VM, and also create snapshots and clones of VMs. Node Client is the command line utility used to access Node Wizard remotely. The key feature of this utility is its ability to fully automate the VM creation process with a single command. Also, multiple hosts can be managed using a single Node client. Presentation overview. In this presentation, we will start by going over the steps to install Node Wizard and Node Client. Further, we will register a server and request a license. Then, we would validate the system information and Node Wizard environment variables. Next, we will look at creating VMs and attaching or detaching components from VMs. After this, we can create snapshots and look at how to roll back VMs to a snapshot. Later, we will look at creating VM templates and clones. Finally, we will have a look at the steps to clean up VMs and the known servers for Node Client. Now, we are ready to go over the syntax and demonstration videos for all the sections mentioned here. Node Wizard and Node Client installation. In this section, we will look at installing Node Wizard and Node Client. To do so, we will start by downloading the Node Wizard and Node Client files from GitLab. Then we can set up the prerequisites and install Node Wizard and Node Client on their respective hosts. Now, let's have a look at the demonstration video for installing Node Wizard and Node Client. First, we start by finding out the Ubuntu version of our Node Wizard and Node Client host machines. The OS release file shows that a Ubuntu 20 machine was used for both the Node Wizard and Node Client hosts. Currently, Node Wizard and Node Client support the Ubuntu 20 and 22 hosts. Also, there are no OS matching requirements. This means the Node Client and Node Wizard can be installed on different OS versions. Now, let's switch over to the browser and open the GitLab page for Cluster Wizard. Then we can click the download link to open the Downloads page. Here, we must select the appropriate Node Wizard installation based on our OS variant and version. To enable the download button, please click on the software license link and read it carefully. After this, you can close the tab to go back to the Downloads page and download the Node Wizard tarball. Now, let's follow a similar procedure to download the Node Client tarball. Now, we can switch back to the terminal window to set up the prerequisites for the Node Wizard installation. We will start by opening the netplan file to reveal that we have two interfaces. We need one interface with internet access to set up Node Wizard. We select the interface ENP6S0 and add a network bridge BR0 external to it. This bridge is required by Node Wizard to expose network traffic to the VMs. Now, let's use the netplan try command to test and apply this new netplan. We can then verify that the bridge is created using the IP address command. Further, let's use the IP route show and systemd resolve status commands to get the gateway IP and the DNS IP. Let's untar the downloaded Node Wizard file and change directories to the extracted folder. Here we can run the deploy Node Wizard script and enter the gateway and DNS IP when prompted. In this demonstration video, we have not used cephrbd. Now the script will start installing all the necessary packages. This should take about 6 minutes to complete. Depending on your installation, You may need additional time to download ISO images. Lastly, we can see that the Node Wizard was installed and the symlink has been created. We can also see a note that KVM acceleration is supported and can be used. Now let's switch over to the host on which we will install Node Client. Then we can untar the downloaded file and change directory to the extracted folder. Let's run the deploy node client command and wait for it to install all the dependencies. Finally, we can use the source command provided on the screen to source node client and test it using the help string. This concludes the Node Wizard and Node Client installation section. License and Server Management. In this section, we will have a look at the license and server management process. To do so, we start by registering a server and listing the known Node Wizard servers. Further, we will request a license using the terminal UI and set up the license to access the server. Let's have a look at the syntax for the commands used in the License and Server Management section. The register server command registers the gRPC server as a known Node Wizard server. This command needs the server address as the input. The list server command is used to list all the Node Wizard servers known by your Node client. This command does not need any additional inputs. The request license command opens a terminal UI to send a license request to the license server. Again, this command does not need any additional inputs. Lastly, the set license command sets the license in the license list of the program. This command needs the license file as the input. Now let's have a look at the demonstration video for registering the server and setting up the license. We start by checking if the CA certificates package is installed on our system. Let's pass the Wizard client host's IP address as an argument to the register server command. Then we can use the list server command to verify that the server was successfully registered. Now we can use the request license command. For this video demonstration, we select the 7-day trial license. Further, we enter the first name, last name, company, and email address. Then we can select the server name and click on Save to send the license request. This would send an email containing the license to the specified email address. Let's head to our email client to see if we have any new emails. We can see a new email from clusterwizard@corespec.com. Here we can see the duration for which the license will be valid and download the attached license file. Let's switch back to the terminal window to set the license. We can pass the downloaded JSON file to the set license command to set up our license. This concludes the license and server management section. System and Node Wizard Management. In this section, we will have a look at receiving basic information from Node Wizard and updating environment variables on the host machine. Here, we can use Node Client to obtain the server's information and also get the version information about the Node Wizard server. Further, we will get the server's environment variables and have a look at modifying them using the set host environment command. Let's have a look at the syntax for the commands used in the System Management and Node Wizard Management section. The System Info command lists the system information like the CPU, memory, disk, etc. This command needs the server address as the input. The version command is used to print the Node Wizard software version. This command needs the server address as the input. The get host env command prints the environment values set for the server. Again, this command needs the server address as the input. Lastly, the set host env command sets the environment values of the server using the key, pool, gateway, or name servers. This command needs the server address, key, and value as the inputs. Now, let's have a look at the demonstration video for receiving basic information from Node Wizard and updating environment variables. We start by using the system info command along with the server's IP address to get the server system information. This shows that the host has the Ubuntu 20.04 OS, with 8 cores and 15.6 GB of memory. We can also see the disks and VM information here. Let's use the version command to get the Node Wizard version. Now we can use the get host env command and parse the output using JQ. Finally, the set host env command can be used to update the name server. The output shows that the value for the name server key was updated. This concludes the System and Node Wizard Management section. VM Management. Create VMs. In this section, we will have a look at creating and accessing VMs. To do so, we will start by using the VM create command. Further, we can use the VNC display to access the VM. Lastly, we can use VM start to start a VM, and dump XML command to get the XML config. Let's have a look at the syntax for the VM management commands used in the Create VM section. The VM create command creates a VM using the specified JSON file. This command needs the server address, VM name, and the JSON file as the inputs. The VNC display command shows the IP address and port number of the VNC display for the server's VM. This command needs the server address and VM name as the inputs. The VM start command is used to start the server's VM. This command needs the server address and the VM name as the inputs. Lastly, the dump XML command is used to get the server VM's XML configuration. Again, this command needs the server address and the VM name as the inputs. Now, let's have a look at the demonstration video for creating and accessing VMs. We start by getting the description of the VM create command. Here we can see the JSON file format expected by the VM create command. The example JSON file used for this demo is shown on the screen. We can see that the VM will be configured to have 4 cores and 8 GB of memory, with a 20 GB disk. Let's use the VM create command and pass this file to create the Ubuntu 20 VM. We can use the VNC display command to obtain the VNC port for the VM. Now let's switch over to the VNC viewer to have a look at the VM install. Node Wizard supports automated VM installation and setup. The Ubuntu 20 installation needs about 30 minutes to complete, but could take longer depending on your host machine's specification. Now we can head back to the terminal. Listing the VM shows that it is in a shut-off state. Let's use the VM start command to start the VM. Now we can go back to the VNC to see the first boot. We can enter the login and password used during installation to log in to the VM. Let's head back to the terminal window. Here we can use the list command to verify the VM name. Further, we can use the dump XML command to get the VM's XML configuration. For simplicity, we used a grep command to view the name, memory, and cores allocated to the VM. This concludes the VM Create subsection for VM management. VM management, attaching components. In this section, we will have a look at attaching various components to a VM. To do so, we will use the VM disk attach command to attach a disk, then use the VM bridge attach command to attach a network bridge, and finally, use the VM host dev attach command to attach a device. Further, we can use the VM shutdown command, followed by the VM start to reboot before testing the attached components. Let's have a look at the syntax for the VM management commands used for attaching components. The VM disk attach command creates and attaches a disk to the server's VM using the specified JSON file. This command needs the server address, VM name, disk target, and the JSON file as the inputs. The VM bridge attach command is used to attach a network bridge to the server's VM. This command needs the server address, VM name, and bridge name as the inputs. The VM host dev attach command is used to attach a host device using a given PCI address. This command needs the server address, VM name, and PCI address as the inputs. Lastly, the VM shutdown command shuts down the server's VM. This command needs the server address and the VM name as the inputs. Now, let's have a look at the demonstration video for attaching components to a VM. We start by using the list command to check if the VM domain name exists on the server. Let's use the describe command to view the JSON file format. Here we can see that we need to provide the image type, size, format, and local path as keys to the JSON file. The JSON file we used for this demonstration is shown on the screen. Now we can use the VM disk attach command to attach the disk to the VM. Further, we use the VM bridge attach command to attach the virtual bridge 0 to the VM. Lastly, we can use the VM host dev attach command to attach the virtual function with the PCI address 6601.2. As shown in the output, the VMs need to be restarted to view the attached components. To do so, we will use the VM shutdown command. Wait for it to shut down. Then use the VM start command. Let's list the VMs on the server to ensure that the VM is in a running state. Now we can use the dump XML command and copy the output to a file. We can then use the following 3 grep commands to verify that the disk, bridge, and virtual function exists. Finally, we can connect to the VM using SSH to run commands to verify if the components are detected. We use the lsblk command followed by a grep statement to find the attached 32 GB disk. As we can see, this disk does not have a partition, file system, or a mount point. Further, we can use IPA and grep for the MAC address we found using the dump XML command. This shows that the new bridge was detected and assigned the ENP8S0 interface. Lastly, we use the lspci command and grep for virtual function. This shows the attached Mellanox MT27710VF. This concludes the attaching components subsection for VM management. VM management, detaching components. In this section, we will have a look at detaching components from a VM. To do so, we will use the VM disk detach command to detach the disk, and use the VM host dev detach command to detach the device. Let's have a look at the syntax for the VM management commands used to detach components. The VM disk detach command detaches the target disk from the server's VM. This command needs the server address, VM name, and the disk target as the inputs. The VM host dev detach command is used to detach a host device using a given PCI address. This command needs the server address, VM name, and PCI address as the inputs. Now, let's have a look at the demonstration video for detaching components from a VM. We start by using the list command to check if the VM domain name exists on the server. Now we can use the VM disk detach command to detach the VD disk from the VM. Further, we can use the VM host dev detach command to detach the virtual function with the PCI address 6601.2. As shown in the output, the VM needs to be restarted before checking for the detached components. To do so, we will use the VM shutdown command. Wait for it to shut down. Then use the VM start command. Let's list the VMs on the server to ensure that the VM is in a running state. Now we can use the dump XML command and copy the output to a file. We can then use the following two grep commands to verify that the target disk does not exist and that the host device was successfully detached. As expected, there is no output, suggesting that the actions were successful. Finally, we can connect to the VM using SSH to run commands to verify if the components are detached. We use the lsblk command followed by a grep statement to search for unpartitioned disks. As expected, we can't find the previously attached 32 GB disk. Lastly, we use the lspci command followed by a grep statement to search for available virtual functions. Again, as expected, we can't find the previously attached VF. This concludes the detaching components subsection for VM management. Local snapshot. In this section, we will have a look at creating, using, and deleting VM snapshots using Node Client. We will start by creating a VM snapshot, then listing snapshots. Further, we will look at how to roll back a VM to a snapshot, and we will finally delete a snapshot. Let's have a look at the syntax for the commands used for snapshot management. The take local snap commands creates a snapshot of the server's VM. This command needs the server address, VM name, and snapshot name as the inputs. The local snapshots command lists the local snapshot of the VM present on the server. This command needs the server address and VM name as the inputs. The rollback local command is used to roll back a server's VM back to a specified snapshot. This command needs the server address, VM name, and snapshot name as the inputs. Lastly, the delete local snap command deletes a snapshot for the server's VM. This command needs the server address, VM name, and snapshot name as the inputs. Now let's have a look at the demonstration video for creating, using, and deleting VM snapshots. We start by using the take local snap command to create a snapshot of the current state of the VM. This process should take about 20 seconds to complete. Next, we can use the local snapshots command to verify that the snapshot was created successfully. Now let's start the rollback procedure. To do so, we start by shutting down the VM to be rolled back. Then we can use the rollback local command to roll back the VM to the specified snapshot. Finally, we can use the delete local snap command to delete a snapshot of the VM. Using the local snapshots command after this shows that the snapshot does not exist. This concludes the local snapshot section. VM template and clone. In this section, we will have a look at creating VM templates and clones. To do so, we will start by creating a template. Then we will get a list of available templates. Finally, we will clone a VM using the desired template. Let's have a look at the syntax for the commands used for creating templates and clones. The VM template local command creates a template from a server's VM. This command needs the server address, VM name, and template name as the inputs. The VM template local list command prints a list of templates on the specified server. This command needs the server address as the input. Lastly, the VM clone command clones a VM using a specified template. This command needs the server address, VM name, template name, and IP address as inputs. The IP address in this case can be DHCP. Now let's have a look at the demonstration video for creating templates and clones. We start by creating a template of the Ubuntu VM using the VM template local command. This process takes about 30 seconds to complete. Then we can use the VM template local list command to verify if the template has been created. Now we are all set to create a clone of the Ubuntu VM. This process takes about 20 seconds to complete. Let's use the list VM command to view the clone VM. Further, we will use the VM start command to start the VM. Then we can use the VNC display command to obtain the VM's display port. Let's switch over to the VNC viewer. The cloned Ubuntu VM should now boot up and go through the grub menu and initial setup. Here we can see that the host name is being set as clone Ubuntu 20. Now let's log in using the cluster admin account and print the OS release file. This concludes the VM template and clone section. VM management, cleanup. In this section, we will have a look at cleaning up the VMs and the known node wizard server list. To do so, we will start by shutting down a VM using VM destroy. Then we can delete the VM. Finally, we will have a look at the unregister server command. Let's have a look at the syntax for the commands used in the VM management cleanup stage. The VM destroy command can be used to destroy a server's VM. This command needs the server address and the VM name as inputs. The VM delete command can be used to delete a server's VMs, along with the VM snapshots. This command also needs the server address and the VM name as inputs. Lastly, the unregister server command is used to unregister the gRPC server from the known node wizard server list. This command needs the server address as the input. Now let's have a look at the demonstration video for cleaning up VMs and unregistering a server. We start by listing the desired VM to ensure that it is in a running state. Then we can use the VM destroy command to destroy the VM. Now we can see that the VM is in a shut-off state. Let's also list the local snapshots of the VM. Let's use the VM delete command to delete the clone Ubuntu 20 VM, along with its snapshots. As expected, listing the VM does not generate an output, and listing snapshots shows that the domain was not found. Let's use the list server command to get a list of the registered servers. We can pass this server's address to the unregister server command to remove it from the known node wizard server list. Finally, using the list server command again shows that the server no longer exists in the known list. This concludes the cleanup subsection for VM management. Thank you for listening to this video presentation for Node Wizard and Node Client. Please use the QR code provided here to get to the downloads page, and send any questions to clusterwizard@corespec.com. A new version of Node Wizard and Node Client is expected to launch by the end of Q3 2024. This version extends the host and guest OS support as shown in this table.